Now let's take a closer look at what's happening on slide 13. We've graphed our constraints here and we have our feasible region shaded in gray. We are going to use a system of equations to figure out the point that I have circled here, the intersection point. That's the extreme value where these two lines intersect one another. So that's considered to be a solution of the system of equations that makes up those two lines. Now in our book, they talk us through a few different ways of figuring out what the maximum value is. We can simply pick a value and calculate our objective function based on that and move our line closer and closer to the edge of the feasible region until we finally get an optimized value. Or we can use Excel. Or if you took my Math 121 class, you know that we are looking at these intersection points, so the intersection of any of our two constraints, we have one there as well, and calculating the optimal value based on that. So I personally think that if you're not going to use Excel, solving a system of equations is the easiest way to do it. However, all three ways work. You can use whatever you are most comfortable with. But let's talk through this one real quick and calculate the point that I have circled. We have two lines that intersect to make that point. Those lines are x1 plus x2 equals 8 and 2x1 plus 3x2 equals 19. So we have two equations and two unknowns here. x1 and x2 are our unknowns. We can solve this either through substitution or through elimination, so trying to get rid of one of our variables and calculate the other one. I'm going to use elimination, but before I can do that, I need to multiply the first equation by -2. That results in -2x1 minus 2x2 equals -16. Our second equation is 2x1 plus 3x2 equals 19. Now if we add these two equations together, our x1's cancel, then we have -2x2 plus 3x2 leaves us with positive 1x2 equals a positive 3. -16 plus 9 is positive 3. So from there, we're halfway there. We have x2 equals 3. We can take that and sub that back into equation 1 or equation 2 and find that we have x1 plus 3 equals 8. Or if I subtract 3, I have x1 equals 5. So I know x1 equals 5, x2 equals 3. If I take a look back at our coordinate system, x1 is in the horizontal direction, x2 is in the vertical direction. So the point that these two coordinates make up is 5, 3. And if we follow along the graph, if we go over to 5 and up 3, it looks like it gets us to that point as well. So now how do I know if this is the optimal value? How do I know if this is the correct solution to maximize my profit? We started out with the objective function of 5x1 plus 7x2, and that's going to give us our values, and we will calculate the value for each of these extreme points that I've circled to figure out what is our actual maximum solution. So if we calculate the value for this 0.53, we're going to sub in our x1 and our x2 values. So 5 times 5 plus 7 times 3 equals 25 plus 21, or 46. So until you calculate the other extreme point values, you don't know for sure if this is the maximum. You just want to leave this off to the side and see if it is. You can follow through the rest of the example in the book and see that this does end up actually being your maximum value or your optimal solution. So hopefully, again, this was helpful to you. Again, you can use any of the three methods that you want. If you need another example of something, just let me know and I'm happy to help you out.